Hello, welcome to our final week of the Modern Application Development course. In this week, we will complete our application and show, and by the end of that, you have seen all the important pieces that go into constructing web applications. Towards the end, we will do a revision of what we have seen so far, and I will also discuss things that we have not seen so that you have some idea of where you can go from this course. In the remaining lectures in this week, we are going to study cookies. We will finish our application logic finally and screen design. We will implement local login and I will show you some security issues that arise in logins. We will look at how externally managed login is done, and then the app is essentially done. We will also discuss some of the features you can add to apps like this, and you should start thinking in this style so that you can develop useful and interesting apps on your own. We will also discuss, like I said, things that we have not seen in this course. Okay. So, cookies, what are they for? A key thing to understand, if you recollect our discussion last week in which we talked about maintaining application state, the ability to refer to an application screen by a URL, and when you visit the URL to be able to see the application where you left it off. That is the fundamental idea behind application state. The protocol itself is said to be stateless. What this word means in this context is that every request to the server, as far as the protocol design is concerned, is independent. There is nothing inherently in HTTP, at least as it was originally designed, that would link one request to another. That is insufficient to build applications, as we will see shortly. TCP, on the other hand, is said to be a stateful protocol because both parties maintain connection information that carries a sort of summary of the historical exchange called a handshake that has happened between the two parts of two ends that create the connection. Statelessness is good because it means that neither party needs to remember much about each other, or at least not remember in a way that is crucial to the functioning of the protocol. So for example, when you maintain a connection, right, a phone connection, let's say, or a TCP connection, which is more or less the same thing, both parties have to agree to talk. One has to agree to lift the phone, the other has to press the button and create the call, and they both need to maintain their respective roles, otherwise the connection can get dropped. In contrast, a HTTP request is something like a letter. Let's say you write a letter and then all you know is, okay, the letter has reached the person. Or in the context of phones or WhatsApp for that matter, right, email, you send a mail and it reaches the person. You may know that it has reached them, but that's about it. You don't know anything else. You may get some response back from them, and the very minimal necessary response is, yes, I received your letter. But the subsequent letter may or may not carry any connection to the first one. That is up to you and the party you are communicating with. So in this sense, when neither party is obliged to maintain a contract of behavior across multiple messages, you can do interesting things like rapidly interleave a communication you are having between, say, 5 different people, and they wouldn't necessarily know, and your capacity, you can just refuse to talk to somebody in the middle and they cannot do anything about it in a sense, right? Now, in a connection-based system, that's not quite the case. Once you agree to hold a connection, there is an implicit contract that you won't break it until both of you are happy with the breaking. Now, This is not hard and fast, right? Connections do break and so on and so forth. But at least while that discussion is going on, both parties hold knowledge about each other. So in general, holding knowledge about each other is necessary. For example, as I have said here, state is necessary because in a shopping cart, for instance, one person's shopping cart should not be presented to another for payment, right? They must not accidentally exchange carts. The items that one person puts in their cart should not accidentally end up in somebody else's cart, because if addition of an item into a shopping cart is an independent HTTP request, then anything could happen, right? So that we cannot allow. And if you want to maintain that sequence, then in effect you are maintaining history. So state is a consequence of history, right? It is the current result of a specific historical sequence of events. To the degree that it matters to your application, state may or may not be important. A classic site like Wikipedia doesn't care, right? It just shows you the document, you come back, you don't come back, it doesn't matter. On the other hand, a web store will most certainly care that you complete your payment, for instance, as much as they would prefer it, because that increases their number of customers. So these kinds of things depend on the application. The bottom line is, the important part is, state is the current result of a specific historical sequence of events, and we need a way to represent that. If the protocol is unwilling to represent it because it wants to be a stateless, scalable protocol, then it's the data communicated by the protocol that must maintain state. That's the distinction. So you can always get the effect of having state. The question is whether it is built into the interactions dictated by the protocol or in the data that the protocol carries. In the case of HTTP, we have a sort of a light hybrid. For all practical purposes, HTTP is still stateless, but you can build state on top of HTTP reasonably easily. So when I say things like build state on top, that means there is a way to represent historical knowledge. That's what it means to say build state. Suppose that on a per user basis, right, one way to build state, so to speak, would be to change the structure of the URLs themselves. So you have your corner shop, and it creates URLs like this for a customer called Homi Baba, and they produce a sequence of URLs 1, 2, 3, 4, etc. Then you can say that as far as the server of this Nukkad Dukan knows, you have created a causal link. 1 causes 2 causes 3, etc. But now suppose you save the URL somewhere. The question is, should it be meaningful to Mr. Homi Baba and to Nukkad Dukan when he makes another purchase? The answer is probably not, right? They don't transfer over from one purchase to another. And if you bookmark it, then is it supposed to be meaningful some days from now, etc.? Those kinds of things become issues. So state, and the larger the history you remember, the larger this sequence gets. Furthermore, suppose you branch off, you go forward in one direction in one window, backward in another direction in another window, then you might start putting numbers like this, right? 3.2.1 or something like that to indicate the entire history of exactly what happened. So it may not be enough to just have this much. And in practice, what it shows is the more state you try to encode in the URL, it keeps on getting bigger and bigger. And it's kind of clumsy, and there are problems with bookmarking and so on and so forth. Plus, there is a fairly serious security issue, because if the URL carries its history and you send the URL to somebody by accident, then they can continue your history where you left off. That is actually probably the most serious issue. Otherwise, you could do something to compress the data, etc., etc. But the security factor makes it impossible. Okay. So what do? The answer is to have a different solution. We make a slight change to the protocol. We tell the browser that it should carry along a small piece of data, which is a key that identifies the URLs in some fashion. We use a piece of data as a common key that links URLs issued by a single browser to a single site. And we make a change to the HTTP protocol. We say that we'll add a header to carry the key called cookie, and we add a header to set the key. So the server tells the client that it should set a key, and the client agrees to carry the key in subsequent exchanges. And so clients are expected to send this key to URLs that have a common domain and an initial URL path. We will see all of the details of this in our demo very shortly. Okay, so here is a picture. You have a browser. It makes an initial request. This initial request does not have any cookie or anything, obviously. The browser is visiting for the first time. Now the server in its response sends a header called setCookie and gives a value together with the HTML page that it returns. In response, what the browser says is for all subsequent requests, 1, 2, 3, 4, etc., it will continue sending another header called the cookie with the value. Such cookies can be revoked. You can have a set cookie that removes a cookie, and you can update a cookie, because if another response comes back with a set cookie of the same key as we will see, then the current value gets updated. So that's something that can be done. And technically, here is what we have. When a browser visits a server xyz.in, the server sends some data called a cookie to the browser in the response header. A browser remembers this data and includes it in the future request headers. A server can tell a browser how long to remember it. This is quite important. So the default is until the close of the browser. As soon as you close the browser and restart it, the cookies are gone. Such cookies are called session cookies. Now, that word session gets used in two different ways in this world. One, a browser session is from when you started the browser to when you stopped. Whereas a server session is when the client first contacted the server and then did not contact it for sufficient amount of time that the server forgets about it. So those are the two ideas of session. And session cookie refers to a cookie that the browser maintains until the close of the browser. In another case, a server can send an end date. It can say that you should expire this cookie by such and such a date, and you can give a date arbitrarily in the future so that the cookie supposedly the client is supposed to preserve it forever. Of course, this can only be advisory, right? Because you can destroy cookies, and the client may say, oh well, I have too many cookies, I'm just going to get rid of some of them. So there are no guarantees in this business. So in that sense, you are carrying the state information in the protocol. You are carrying the state information in the data conveyed by the protocol, not the requests of the protocol itself. In contrast, in TCP, you may have seen there is something called a TCP state machine. If you haven't seen it, you can look it up on Wikipedia, where there are states that tell you where the two parties that are talking to each other are, that maintain what is happening with their connection. Okay. So in general, the server and browser are independent of each other. A server cannot force the browser to do anything. This is crucial, because this means that server and browser are independent enough to evolve independently as long as they use the same protocol in talking to each other. This is quite a magical idea, although it's difficult to explain just exactly what is magical about it. The magic is apparent historically. This was not an obvious idea to invent, and previous methods of building distributed applications, there were systems called Corba and this and that. they were quite terrible, to the point where they are more or less forgotten. That's not to say everything was terrible, just lots of things were terrible. In comparison, the web and the HTTP protocol are wildly successful because they carried this notion of protocols rather than the methods that Corba used, like language-based interfaces and whatnot. And it's sort of difficult to overstate just how amazing the idea is, but it's not that easy to explain unless you have actually experienced how people were thinking in the absence of the world of protocols. And these ideas are some of those things that seem obvious in hindsight. Of course, not all protocols are the same. HTTP is a particularly interesting design, and we will briefly talk about the philosophical ideas in HTTP as we close the discussions in the course. Okay, so that's one part. Now the second is the meaning of the cookie resides in the server. It's meaningless to the browser. The browser just blindly sends the cookie, and whatever the server does, it does. Once a server receives a cookie, it can decide what to do about the request. It can check whether a cookie is valid. It can check whether it is too old. If it's neither, then you can use the cookie in some fashion to respond to the user. Okay, so with this background, let's do a demo of cookies. To be able to play with cookies, you really need this browser add-on called Cookie Quick Manager. This add-on, this is the tab I'm going to use to start the manager, and you can follow along. You can install this Cookie Quick Manager, and then when it's installed, you will see a little Cookie Quick Manager thing icon here. So when you press this icon, it gives you these options, and then it says manage all cookies. So when you start looking at all cookies, because we have recently visited this domain addons.mozilla.org, you can see that both .mozilla.org and addons.mozilla.org have set a bunch of cookies. We are not going to spend time trying to understand these cookies because I don't know much about them, first of all. And anyway, we are going to run our own cookie demo so that you can understand what is exactly going on. But let's just go over what this shows. It says that cookies are associated with a domain. Like I said, the HTTP protocol was changed to agree that the client will supply a cookie to the domain where it came from, but not just the domain. There's something else called the path, which also plays a role, and we will see an example of that shortly. So it says that this cookie, for instance, has the name _GA, and its value is this. Now, whatever it is, it carries some meaning to Mozilla. They are using it to track something or the other. And it's supposed to expire at this time. So in 2022. So these guys are, Mozilla is a open source company, so there is nothing nefarious going on. You have probably heard about cookies being bad and whatever. Yes, if they are used by some non-public concerns, let's say, but a place like Mozilla doing this is perfectly fine. Here is another one, GID. So you have name GID and something, and then there's something else, and this cookie is in a different font for whatever reason. I don't see what is different about it, but anyway, probably doesn't, something or the other, some detail that I don't know. Okay, so here is the other thing, addons.mozilla.org, and it contains some other thing, and as you can see, the value is this blob, whatever it is. It says it's base 64. So let's see what it does. I guess not much meaning is there in this cookie as far as base 64 is concerned, so it's some other format. In any event, these are the things that matter. Now let's go to this tab and start our friend the manager. As soon as you visit Tomcat, let me refresh this guy. Okay, it hasn't happened yet. Let me, okay. It's not just Tomcat. You have to start one of these servlet managers. So I have my manager, password, and then we have the manager. When you log into the manager, you can see that we got a new cookie here for localhost. And the localhost cookie shows that it is a JSessionID cookie. So this JSessionID, about which we will learn shortly, is a cookie that is set by the servlet container, which is Tomcat, and it has some value here. It says that this cookie is valid for the path/manager. So the URL has to be localhost/manager. If the URL you are contacting has this part, localhost/manager, as its starting part of the path, then the browser will send the cookie to the application, the manager application itself. Another thing it notes is this is a HTTP only cookie. So if we had a HTTPS connection, this will not work. And it's said to be a session cookie. Now, if you recollect, a session cookie is supposed to be here. So until browser close. So this is called a session cookie, as opposed to this cookie from Mozilla, which had an expiry date, and it is not a session cookie. It is not HTTP only, so this will get sent to both HTTP and HTTPS. And the path is / here the path is /, so which means every single path on mozilla.org will receive this cookie. There is some other thing here about strict and lax and whatnot. There are lots of details like this in the web thing. If you do it professionally, you have to know that, but for basic concepts, this is what we are doing is good enough. Okay, so here we are. We have created a new application called Cookie Hello, and we are going to demo it. So let's open Cookie Hello. All right. What Cookie Hello does is it takes the same form that we have been working with, just changes it to do these three activities: set cookie, delete cookie, and persistent cookie. And then it shows you which cookie you have, what is the name, and what is the value. All right. Now what does let me get rid of this add-on tab. And what does our system say? So if you notice, this number changed. We now have 2 cookies. And we have 2 JSessionID cookies. One is the first one, which is /manager. And the second is from Cookie Hello. So because Tomcat is a servlet container, as soon as a browser visits it for the first time on a unique path, it issues a new JSessionID cookie. This is standard built-in functionality for session maintenance, whose utility we will see in a short while. Okay, so already we have had our first result. Now, see, this page is supposed to show you the cookies. So there is a problem. What happened? Why did the system not show the JSessionID cookie? The answer lies in something fairly interesting. So the cookie has been set and the cookie has been received, right? So which means our browser currently has this cookie. But consider how this page was created. When the page was created, there was no cookie, right? So because there was no cookie, the page was created on the server side. The server is showing you the page as it saw at the moment you made the request. Okay, at that time there was no cookie. Now let us see what happens if we make the same GET request again. Okay, watch. The session ID cookie we have is this. Our cookie hello application is here. When we went to the server for the first time, the server made the web page, sent it to the browser. There was no cookie visible to the server at that time. But we know there is a cookie because the browser add-on is telling us there is. So let's see what happens. As soon as we made the second request, the cookie is now visible because the server had access to the cookie, even though we made the same request again. So let's see what the server saw. Okay. So the request headers look like this. The browser is sending this cookie 1B5A, etc., etc. And this is the same cookie that we see in this cookie manager, right? Let me maybe move this to a new window so that we can see both at the same time. So here we have it, and here is our JSession ID cookie 1B5, etc., etc. is 1B5, so on. So the request had sent it, which is why the server could see it. How did the server see it? Let's look at some code. Okay, so when we made a GET request, the server ran this thing from the cookie hello class. It got the hello JSP and ran this function show cookies, which looks like this. You can read about this part on the web for how to see cookies in a servlet. The basic idea is the HTTP request object has a function called get cookies, which returns an array of cookies. And we do exactly what we did for the database. We loop through the cookies and turn the name value pairs into a list of maps, right? In this case, there is only one map in this list because all the cookies are stuffed into a single map. But by doing this, we can use the same JSP code that we had used previously, which is this one. So hello, and here we are. So we have a for each with name value pairs. This for each loop, which loops over this thing called cookie data and CK name and CK value, is generated here. So we set the attribute cookie data and we create this list. So what happened is the browser sent the request, the server extracted the cookies from the request itself. It didn't go to the database, just the request, and then generated the page and sent it back to us. Now, if we repeat this, there is no new cookie getting set. So nothing is happening even though we are making the request again and again. And here is what we have. This is the local cookie thing. Okay, so that's as far as setting the J session ID cookie is concerned. But in this application, we are going to do something kind of interesting. We will actually send a key value pair, and you can put anything in here, a key value pair. And on the server side, we are going to take this key value pair and turn it into a cookie and set it. Okay, so let's do a set cookie call. Watch this. We are going to make a post call. So we made the call, and this is what the headers look like. So the request header, right, is a post header. It still carries this cookie, but we are telling the server what cookie to set via the field. So the field is a plus 3734 blah blah blah. And this encoding of space as plus is a standard thing that happens called URL encoding. I think we have talked about it before, but if not, you can look it up. The name is URL encoding. In any event, this is what we have sent. And then look at what happens. The server sends back a response which actually contains a set cookie. And if we look at if we refresh this thing here, localhost now shows us 3 cookies. So this is our cookie. So in fact, the browser has received the cookie. But as before, right, because the server generated the page for us, it's still not showing the cookie. And if I do a refresh, we will see the cookie. So that's the basic idea. Now, deleting the cookie, same kind of thing. You just say which cookie you want to delete. We will hit it. And here is what we have. Okay. So our request was like this. Our request was, the body of the request is here. We have said the field is A and the button is delete. Then what happened was, the browser processed this. It's still sending the cookie because we haven't deleted it yet. The request goes through. But then the browser comes back and says, set the cookie to empty, right? And set its expiry date in the past. If you look carefully in your own browser, this is a little too faint. In your own browser, then you will see that the expiry date has been set to 1 Jan 1970, which is basically in the past. And so the cookie should be deleted. But because the page was generated when the cookie was still there, we still see it in the page. If you wanted to, you could write some JavaScript code to make this happen directly on the client side, but that's okay. This way you understand the cycle better. And now if you refresh it, right, I'm just hitting refresh, the cookie is gone. The cookie for localhost is gone. So the browser has already deleted it. And now if we refresh again, the cookie is gone. So that's set and delete. So delete is basically setting the cookie, right? Here, if we use our standard style, which is to get the parameter and say set, delete, and the persistent cookie, then what we see is, if you want to set a cookie, you get the parameter, split it on space, and to the response object, you run the add cookie command and add a new cookie object. For delete, you get the cookie name from the field, generate a new empty cookie, set max age to 0. So 0, because of the Unix heritage, is interpreted as 1 Jan 1970. And when you add the cookie, the browser goes and removes the cookie. Next time around, that is. That is, next time there will not be any such cookie in the request it sends. Okay. Now one thing about, so I'm going to set a few cookies to show you what persistence and not persistence means. So I have set cookie. Again, the update hasn't happened, and then I have something. Again, set cookie. And now I see the previous cookie. If I want to see the current one, I can do resend, and I will see. Of course, it doesn't have to be a resend of the form. It can just be a get request. That part doesn't matter at all. So even if it's a get, you will still see the cookie back because of the way we have written the code. That is, we haven't bothered about get or post. Just show cookies happens in either case. So here we actually take the actions such as setting and clearing and then show the cookie. Here we don't take the action and just show the cookie. All right. So that's the basic idea. And so I have a bunch of cookies here. If I refresh this, if I refresh our add-on, then the two cookies are visible. What you will notice is that we have the key value, we have a key value, we have a context, which is the cookie hello, and these are session cookies. So which means what I expect to happen is when I close the browser and restart it, the cookies should not be there. On the other hand, I am going to set another cookie, I don't know, whatever, BBBB, and 1 2 3 4 5, set it as a persistent cookie. Here let's take a look at the request. What it says is set a cookie with an expiry date. So I'm setting it to expire at 3:40 GMT, whatever it is, and about an hour or so. How have I done it? The code is here. We set the age to, so the general idea is, seconds, minutes, hours, and days. And so this is basically set to 1 hour. So in another hour, if we close the browser and get back, the cookie will be gone. But we're not going to wait that long. I just want to show you the difference between persistence and non-persistence. So the persistent cookie hasn't shown up. I'm going to issue a get request and I can see my BBBB, which was a persistent cookie. If you go to our add-on and you hit refresh, what we see is a cookie called BBBB, which is not a session cookie and it's going to expire in an hour. All right. So now what I'm going to do is just close the browser down and restart it. So we have exit. And I have this DevFox thing. Okay. So let's open a new window. And in that window, I will start the cookie manager. As you can see, localhost still has one cookie, BBBB, 1232, etc. So that's a persistent cookie. Reasonably straightforward, kind of elegant, and once you have this add-on, cookies are pretty easy to understand. They are also visible in the standard inspector and so on, but just to show you, technically you don't need the add-ons and whatnot, but the add-ons make the interpretation much easier. So we have our toggle tools, and if you go look at this stuff, I think it's somewhere in memory. Storage. There we are, cookies. That's surprising. Okay, I'll have to look at this to see why it is not showing the persistent cookie. Maybe it keeps it somewhere else, I don't know. Okay, so if I find this out, I'll show you next time. All right, so that is our discussion of how cookies work, right? And what we are doing in our demo is not usual. We are letting the client specify a cookie. Normally the server will just do it on its own. And so what we have is we are sending this form field, right? And then there is a set cookie call coming back from the server telling us to set the cookie. You can, again, in JavaScript, set a cookie completely locally. So you can do it all in browser if you want to. And so the effect of set cookie can be seen after one refresh. All right. So in summary, cookie is a series of key value pairs. One key refers to the server session, another can refer to the user ID, username and password, and all can be carried. There are problems doing that in a, it's not a good idea to do it as simply as it seems. We will discuss that in the next session. And if the cookie is not known, then you can take action based on that. So that's the basic idea. And we will now use cookies to implement the login page, understand sessions, and so on. All right. See you next time.